All right. So here we go. We are good to start with today's session. Like I said, we are going to build Symbol Transit, a fictitious bus company, a multi-agent system for the company using LangChain4J and MCP Toolbox Java SDK. Of course, we are going to use Gemini as our Vertex AI, Gemini through Vertex AI as our preferred agent large language model, and we are going to use Cloud Run as our serverless runtime. So what are we building? We are building a conversational experience for customers to check availability of buses or transportation and book. Right, not just discuss, not just talk. Also make autonomous decisions. Also make actionable decisions. Sorry, to go ahead and book it. Also do policy related questions and basic conversation about everything that we have in the information about the symbol transit data source itself. All right. So this is what we are building. Like I already said, we'll dive into the architectural part a little bit later because setting up the database will take 15 minutes. You don't have to sit through each step for those 15 minutes. We can just trigger that on and then we can discuss or deep dive into each and every component of the technical architecture today in today's project. Yeah. So let's get started. So I would request you all to go to step 2 of the code lab, which is before you begin. Oh, one more thing in the overview, we are going to use AlloyDB database for our as our data source. Of course, it's not going to be like tens of thousands of records or anything. We are going to have some hundreds of records, I think, if I'm right. And these records are going to serve as the lookup or the actual availability of buses, the timings and the schedules of the buses and the routes that are available. That's it. And we're going to update some policy information. So that's about it. This is what we're going to store. And then transactionally, when you're booking something, it will get auto inserted or will get inserted depending on what you choose to do in the application. So that's exactly what we are going to store in a database. Why AlloyDB? We have discussed this extensively in our previous sessions. However, AlloyDB is a 100% Postgres compatible, fully managed database, which is basically Postgres on steroids, which is 4x faster in terms of transactional in terms of transactions as compared to your self-managed Postgres, and it's 100x faster for analytical queries in comparison with your self-managed Postgres. Postgres, as we know, is very intelligent data, one of the most intelligent databases out there, right? Even open source. But imagine that on a super high performant and heavily AI infused grade. That's what AlloyDB is for us, and that's the reason this is our primary choice of database for this particular session as well. So let's move on to before you begin step. We already completed points 1, 2, which is setting up the project and setting up billing account. All right. Now we are going to point 3, which is activate Cloud Shell. So go to your Google Cloud Console where you just created the project and created the billing account. Now in the search bar, next to the search bar, you see Google Cloud Assist icon, and right next to it, you see an activate Cloud Shell button. Go ahead and click that. When you activate Cloud Shell, it is assigning a Cloud Shell machine, which contains Cloud Shell editor and terminal. Editor, so you can write and store code, and terminal, so you can interact with Google Cloud Services. It'll ask you to authorize. It's important. Go ahead and authorize. Make sure you choose the same personal Gmail account while you're authorizing that you activated your credits with. Now, when you see this particular Cloud Shell terminal, it should be prompting with your project ID showing clearly. If it is not showing your project ID, you're in trouble. It will give you issues later on. So go ahead and run the commands that you see in the code lab, which is gcloud config set project, and then set your project ID. So copy that line, gcloud config set project, and project ID, you should know that. So how would you know it? Like I said before, there is a project picker drop down. Click that. On the right hand side, you get the ID. It might seem similar in my case, the name and ID, but it's not always the same. If you notice other ones, so ID and name are highly different in certain cases or in most cases. So make sure you copy the ID and save it somewhere handy because we'll use it in multiple places. So copy the ID, come back to the terminal and either copy the command or type the command gcloud config set project and paste your project ID, or type your project ID if you know what it is, and hit enter. All right, so you should now be able to see your project ID displayed in the prompt of your terminal. If you're having issues authenticating other things, then use the command gcloud space auth space login. It'll ask you to authenticate. Go ahead and do it. I'm not going to do it because I'm already authenticated. All right. Now, going back to the code lab, there is a step number 7, point number 7 in second step before you begin. Same page, go to point 7, enable the required APIs, follow the link and enable the APIs. The link word is hyperlinked. Right click and copy link address. Copy the whole hyperlinked text and come back to your Cloud Shell. Don't come to your Cloud Shell terminal. You need to open a new tab or open, right click the Google Cloud logo and open it in a new tab and paste it in the browser, and make sure you're in the right Gmail account so that you're not confusing with some other email ID, right? And hit enter. Now it will load. It'll ask you to select a project or confirm project. Go ahead and confirm, say next. That is your confirmation. So in my case, it is showing my right project ID, correct project ID. So I'll say next. And now it is listing all the APIs that I want to enable for today's project, which is AlloyDB, Compute, Cloud Resource Manager, Service Networking, Cloud Run Admin, Cloud Build, Cloud Functions, Vertex AI. Go ahead and say enable. Once you click enable button, it's going to take you back to, it won't take you anywhere. Just stay here. It'll just say, it'll make the button disabled, which is proof that your APIs are now enabled. It's taking a moment here, so I'm going to wait until that's happening. I did nothing different from what is mentioned in the code lab, so I'll just go over step number 2 before you begin step in the code lab. And point number 7, right-click the link word, which is hyperlinked, and copy the link address and open in a new tab and click next. And click the enable button in the next page. It'll take a couple of minutes to enable all the APIs. All right, now it's done. You should see 2 blue tick marks like you see in my screen, and your enable button should be disabled. Now the APIs that are required for this project are all enabled. So I'm going to go back to the code lab and confirm that I've completed all the steps in this particular, all the points in this particular step. Moving on to step 3, database setup. Now, just a quick thing. What are these APIs and why are we enabling them? These are the APIs that are services, Google Cloud services that we are going to use in this lab, either directly or indirectly. You might not notice why we're using certain things. Like, I already said we're using AlloyDB database. So the first one will make sense. You already know we are using Vertex AI because we already mentioned that we're using Gemini for the LLM for the agent. So you know that would make sense. Why are we using Cloud Build, Cloud Run, Service Networking? Because Service Networking, Cloud Resource Compute are all required for AlloyDB, and Cloud Run is required for our serverless runtime use case, right? So all of these things are required. This is our way of telling Google Cloud that for this project, you're going to use these APIs, so you have enabled them. Perfect. Show of thumbs, how many of you completed this step? Thank you for confirming. Moving on to the code lab, we'll go to database setup. This is the part which is going to take 15 minutes after you trigger the setup, right? So let's do that first and then take any discussion about the architecture and what we're going to build after triggering this step. So what we're going to do here is there is a one-click and run. We're going to set up AlloyDB, and for setting up, you have to set up cluster, you have to set up instance, you have to make all the networking requirements that are required for your instance ready in order to make it a private network. right? You can just make it public as well, but we need to learn how to do it um, how to do it the right way, so you can take it to your projects or your business wherever you're applying it. However, it's been simplified for our needs, so that the time itself, or the time to learn how to do it, is not much, and you can just trigger everything in the background in one click. So that's the goal, right? So you can either click this blue button for it to open in the right account, or if you feel that you have multiple Gmail accounts or multiple user accounts, email accounts, and it might get confused. So if you don't want to click the button, you can also copy the git clone command directly without clicking the button. Most of you can directly click the button. In my case, I don't want to do it because I have a Chromebook and I have multiple accounts signed in. So I don't want it to choose the wrong account. So I'm going to copy the git clone. If you're clicking the button, all you have to do is just click the button and wait there for my instructions. It will ask you to trust the repo, check the checkbox and say confirm. And then it will take you to this page that you're seeing in my screen right now. It'll ask you to authorize, and then it will just bring you to the Cloud Shell terminal with a command loaded, and then it'll have a help tutorial on the right hand side open as well, as you can see in my screen. Right? I don't have enough space in my disk, so it's erroring out, but don't worry about it. This is what will happen when you click, not error part, but this is what will happen in the sense it'll open a terminal, and on the right hand side it'll open a class tutorial, which will give you a run command, but don't worry about it. Just open it and wait for my instructions. All right. Now, for folks who don't want to click the button and want to do git clone, just copy the git clone command first and come back to the tab where you have the terminal open, and making sure you're in the root directory of your Google Cloud project in the terminal. Paste this git clone command and hit enter. So what we're doing is basically we are cloning the repository ECLOIDB setup, so the project gets created in your root folder. Now that you're inside that, sorry, you have cloned it, we need to get into the root of the project, the ECLOIDB setup project. So copy the cd command from the code lab, come back to the terminal, paste it, and hit enter. Now you are inside the root folder of the project ECLOIDB setup. Now this is the project that is going to help you set up AlloyDB easily, the cluster instance and the network configuration part. We'll discuss what it is exactly doing right after we trigger the setup. All right, so now that the git clone step is done and navigation to the folder is done, this is exactly where the folks who clicked the blue button are as well. So you can close the tutorial on the right hand side if you're seeing that in the terminal, folks who click the blue button. And folks who get cloned, you're already here, so please stay here. Now, both of us, everyone in the call, what you need to do next is run this command sh space run.sh, because we have a run.sh file in the folder ECLOIDB setup, which will in turn trigger a bunch of commands that will start our application for us. So type sh run.sh, or you can copy this command from the code lab as well. It's there in step 3 in the code lab and point number 2. Copy that and hit enter. Paste it here and hit enter. And as you can see, it is setting up the application and it'll open it up in your local, as you see right here. So the application is now running on localhost. Right click or just click on it. It'll open it in a new tab. As you can see in my screen, you should be able to see this AlloyDB quick setup, easy AlloyDB setup web interface showing up and running in your local machine, local Cloud Shell machine. You should see 2 tabs, billing setup and AlloyDB setup. And remember, I told you, if you have multiple billing accounts or you're not sure whether the right trial billing account is in fact linked to your project or the project that you want to work on, right? So if you don't know that, this is the step where we fix it. So how will we fix this? Everyone can do this. There's no issue, because even if it's the first time you're using a standard first project in Google Cloud and a first billing account, no harm. You can still do this step, because it's only going to relink your active trial billing account to the project that you want to use in this session. So remember the project ID that you saved, paste it somewhere, go back and get your project ID, paste it in the cloud project Google Cloud Project text box without any space or anything, the exact project ID name, and leave the billing account name empty. Don't type anything in there. We are only dealing with active trial billing account. So you can leave it empty. It will automatically find an active trial billing account. If you have other billing accounts, it will not touch them. It will only look for Google Cloud Platform trial billing account. So don't worry about linking a wrong account or anything. All right, now click the link to active billing account button. It will automatically link one of your active trial billing accounts to the new Google Cloud project that you want to use. And that's it. You should see the message that says successfully linked project so and so to your billing account so and so. You're done. You're done with billing account linking. Move to the second step, which is the main theme of today's, not today, but this part of the application that we are implementing, which is setting up the database and databases cluster and instance and network configuration. So navigate to your second tab, which is AlloyDB setup, and make sure your cloud project ID is already showing. If it's not showing, copy paste the value. I already told you where you can find it. You can find it in the Google Cloud's landing page right here by clicking the project picker and choosing your project ID. Now, leave the region as it is, US Central 1. Leave the cluster name and instance name as they are, unless you already have these created in your current project. If you have the same names for an existing AlloyDB cluster, then change it. If it is not, if it's brand new project, or if you don't have an AlloyDB cluster from the past, then use the same name. AlloyDB password, type whatever you want that you can remember, but I recommend for the sake of today's session, type it as AlloyDB, all small, so that we can all collectively remember. Then click Start Deployment. Once you click the button, it will start loading your logs transparently, showing you the steps that it takes to execute in order to set up your cluster, your instance, your network configuration, and everything, permissions. It validates everything. I have put in some sleep commands in between, just so it, like 5 seconds or 10 seconds, just so it can confidently complete the previous step before moving on to the next. Just in case while it's in transition, we don't want to overlap steps. That's why. So yeah, you can check the logs for what it's doing. However, I also have it in the source code in the GitHub repo, which I will show right now. All right, show of thumbs, how many of you were able to successfully click the start deployment step? Okay, if you happen to encounter an issue or not able to get to that step, please follow the code lab. It's very self-explanatory, and we have done exactly what is there in the code lab, nothing new. Password, you can keep whatever you want, Ajit. For the sake of this session, type it as AlloyDB all small. I don't know where you're clicking start, Sachin. You just have to click the local URL link, the 127.0.0.1. All right, I want to walk you through what the code is doing behind the scenes. The run sh, when you did that, it will behind the scenes call the AlloyDB script, which is actually what we are running. It basically takes your inputs for project ID, region, password, cluster ID, and instance ID. And with the default names that we have created for VPC name, subnet name, and PSA range, it will start first validating whether your environment is authenticated. Then it'll move on to make sure your project is set. And then it'll move on to verify if you're not authenticated, it'll run the auth login step for you, or it'll ask you to run the auth login. If you see this error, then you have to run the gcloud auth login in your terminal, and verify the authentication, and then you have to proceed with running the application again. In that case, you probably want to change the cluster name if you're rerunning the application, in case it wouldn't have created anyway. So you can rerun the process again and just go with the flow again if you encountered this error. In my case, I didn't encounter that error, so it is actually running the next steps, the following steps, which we'll see what it's doing right now. So it's going to enable APIs, and then after enabling APIs, it goes into sleep for 10 seconds, and then it goes to network setup. This is where it's creating VPC, and then it is creating subnet, and then it is creating the private service access. And then it's ensuring, and then it's checking if the range exists and the peering is established. If not, it does those things. And then it sleeps for 10 seconds and it moves on to creating a cluster. Again, after that, it moves on to create instance. And then finally, it says deployment complete, check console. And in my case, it's actually creating an instance right now. The console is a summary tab. If you go to summary or the console here, we can check whichever to confirm. But if you have to go to summary tab, which it will by default take you. It will give you the credentials of your instance, which is the cluster instance host, that is this IP address and the port of your database that you need to copy and paste somewhere, because we will need that for our application today. All right. So this is where we are, and it'll take a few more minutes for this instance creation to complete, because this is the step that takes. Oh, wait, I got resource exhausted. But I think that's okay. There is a way for it to self-heal. So I'm hoping that it is already done. Let's see what happens. Okay, in my case, there is a resource, the quota is actually reached for running the APIs, and that's probably why I'm getting this. I can run it in another account. That's not a problem. Let me see what is the billing value I have. Yeah, I do have $5, so that's not an issue. Mm. Okay, so probably it is the load that we have at this point, and that's okay. That's not an issue. Because it's a trial billing account, there's a chance that some of you encountered this issue. Usually when you do it at your own pace and you restart this and you try this again, it'll work. You should be able to get going with this. However, I want to ask if anyone was able to successfully get their instance created, or in case it's still uh, in progress for some of you. Can you please confirm how many of you were successfully able to get the cluster and instance created for you? Great. Some of you in progress. For the next few minutes, it'll be done. However, don't worry, for those folks who were not able to deploy the cluster and instance, that's okay. It's because we are using a trial billing account one, and we're all trying it at the same time in the same region. So that's another reason why this is probably this is probably happening. Don't worry about this. There is a deployed link which I'll be sharing with the folks, so we'll all be able to use that. So even if it is not created or it's erroring out, that's okay. Just hold on. But ideally, if I run it from a different account, without a trial billing account, or even if it's a one that's less taxed at this moment, you will be able to see um, it's set up really quickly. I'll show that. Right. So I'll show how to do that right now. Okay. So I'm just repeating the steps in another environment so I can show you what the result looks like. It's pretty straightforward. You'll be able to get going with the cluster instance. A lot of folks did it even yesterday and they were able to get it. So it's something very specific to the trial credits that we are using today. All right. So it'll be running in the background. Don't worry about it. Let's move on to the next step in the code lab. Don't worry for folks who encountered the issue that I showed in my tab right now. Don't worry about this. It clearly shows resource exhausted. So it's because of the number of limits of APIs that we can all request at the same time, or I've been trying to use in this for this email account at this time. So that's why you're seeing this. Moving on to the code lab, let's assume that the cluster and instance has been created for us, right? I'll show you that in a bit. Anyway, we are running another instance in the background. So I'll show that once it's complete. Even otherwise, I have this cluster and instance ready for a session today in case an incident like this happens, because I know this with trial billing account, anything can happen. So let's move on to that part. So I have the cluster and instance already created right here. So I'm navigating into the instance. Currently, we have the way you have set up for folks who have set up the cluster and instance right now through the process that we just discussed. You will notice that it is set up for private network. It's not public. So I'm going to show you right now how to make a private network public, which you probably already know, but where to find it in AlloyDB console is what we're going to see right now. So if you scroll down right here in your cluster page, you'll see the instance name, and you'll see the connectivity link, which shows view connectivity configuration. So click that. You should be able to see a public connectivity disabled in your case. So if it is disabled, change that, edit it here, and change check the box for enable public IP. It'll ask you to confirm that, and add in your authorized external network as 0.0.0.0/0. That will expose your database to be public. This is only advised for development environments, or not even. You don't even have to do this for today's session, but in case you want to try it out from your local machine, you would want to include the public IP there, and that's the only reason. Otherwise, it's not recommended to use it for your actual production grade applications, right? So there we go. We have our cluster and instance ready, and I'm navigating to AlloyDB Studio from here. But before we go there, see, as you can see right here, this is still going on. My instance setup is still going on. Once it completes, I'll show you what your output looks like, so that you will know when you do it at your own time later. If you want to use AlloyDB, you can use this utility and you see what you can get it. All right, what you can get when you use this utility to set up cluster and instance. Now, for folks, yeah, the public part I'll repeat in a bit. But for folks who already triggered the process and it was still going on without issues, have you been able to successfully complete it? Can you please confirm? Okay. Yeah, that's great. Yeah. So if you had no quota issues, you'll probably get that successfully complete. All right. Feel free to use your own database and your own instance throughout the rest of the session. For folks who encountered errors, you can use the API link that I will give you at that point. Don't worry. If it says completed with warning, see what is the warning. If you're able to see the summary tab with the IP, with password, sorry, not password, port, and with the cluster ID and instance ID, then you're good. That's not an issue. Yeah, if it errors out, like you saw in my case, it won't even be able to create. See, if instance is created successfully, then you're good. For folks who could not create the instance because resource has been exhausted, only we need to use the existing API link, which I'll give you later when we get to that part of the application. All right. So right now we are all set. No, you don't need to use a new project for every session. You can use an existing project. I just repeat the create project sessions because we have a lot of new folks sometimes. So they need to know how to create a new project. You, yeah, you don't need to set up public IP if you don't want to. We will not need that. If you want to set up public IP, yeah, if you got cluster and instance ID in the summary along with port and host, then you're good. All right. So now, someone asked for repeating the public IP step. I'll just quickly tell you because we are not going to enable that right now. But if you need, you can do it. Um, List the clusters, go to the AlloyDB page. How to go to AlloyDB? In Google Cloud Console, in the search bar, type AlloyDB. You will see the top result as AlloyDB for PostgreSQL. Click that, and once you click that, you will be in the AlloyDB's console, landing console, and then scroll down. You will see all the available clusters. In my case, the instance installation is still going on. And I'm going to use an existing instance to showcase this point which I'm making. So click the instance. You should see two check marks, one for cluster, one for instance. Click the instance and scroll down, or just see where you can edit the instance. Scroll down, you can see instance right there. Within edit, the three vertical dots. Click that and choose edit. And once you click edit, you should be able to see, scroll down, you should be able to see a checkbox against enable public IP. The section's name is public IP connectivity. Check that and add 0.0.0.0/0 as your network. That will expose your instance to be public. All right. So now that that's done, come out and from your instance, go to the left-hand side, which is the navigation menu. Under primary cluster, you will see AlloyDB Studio below overview. Click the AlloyDB Studio menu item. It will take you to the AlloyDB Studio. Log into your database pop-up. So click the database drop-down, choose the default drop-down, which is Postgres. Click the user drop-down, choose Postgres. Click the password text box and enter the password and click authenticate. The password, we set it up. If you changed it, type whatever you have. If you didn't change it, it's AlloyDB all small. All right. So I'm here in your case, you will not see any table. You will not see anything in the schema. You'll just see a blank empty placeholder for tables. And on the right-hand side, you'll see a query editor titled Untitled Query. So click that. This is only for folks who have successfully created cluster and instance. For folks who have errors, please don't do these steps. You cannot because your instance is not created. You can just watch me doing this and then you can get the deployed endpoint from me for MCP Toolbox and then we can pick it up from there. For now, you can just watch. All right. So now that we are done with this, let's go to the code lab. Go to step 4, schema provisioning of the code lab. Step 4 of the code lab, which is schema provisioning. Scroll down. We have to enable extensions because we'll be using Google's ML integration, that is Vertex AI, from within the scope of the database itself. And then we'll be using PG Vector for doing vector searches. So copy both the extension commands, statements, and paste it in the editor and run. Again, this part is only for folks who successfully deployed the data cluster and instance. If you had quota issues running that or creating that, don't worry, you don't have to do this step. You can just watch me doing it and then you can get the deployed URL from me. All right, so statement executed successfully. Now to grant permission, grant execute, we'll have to do this step. Copy this grant execute command and come back to the editor, paste it. We are doing this to grant the execute embeddings permission to the user named Postgres. So run this. Why we need to do this? Because we need to allow the user to run embeddings function, because embedding function is a function that converts data into from any format to embeddings format, which is a representation of data in the form of vectors, which is array of floats. All right, so this step is complete also. So I'm going back to the code lab. We are in step 4. We completed granting permission. The next one is granting Vertex AI user role. But before I go into that step, show of thumbs, how many of you? Great, thank you. Pass AlloyDB all small. So the public host and IP that you got is not public. If you deployed the cluster and instance successfully and you got the summary tab values, those are private network credentials. Your IP and port are private. Just keep it there. We'll get uh, f- you have to follow the steps that we're doing right now to create the table. In your case, you all can just watch these steps because I'm going to give you the data endpoint anyway. So just watch this. The data endpoint is useful for us to use that in the application. So wait until we get to the data endpoint part. I'm just going to follow the steps in the code lab so you can understand what I'm doing up until the point where we deploy Toolbox. Don't worry if all of us, like even the folks who got it successfully deployed, you can just listen because I'm going to give you the endpoint for the data orchestration layer anyway. So you all can use it, right? So I'm going to grant Vertex AI user role to AlloyDB service account. Why am I doing this? Because we want AlloyDB data to be able to talk to Vertex AI and run LLMs, right? We want to talk to all the models in Vertex AI. So I'm going to copy this command. This is a Cloud Shell command. So I'm going to go to the console. I'm going to open the editor. Oh, it's already running the application still. Okay. Before I go to that step, remember I told you I'll show what once the cluster and instance is created for the AlloyDB configuration, it will take us to the summary tab, and this is what it'll look like. So it's successfully completed for me now. Finally, the cluster is so and so, instance is so and so, region project. You will get your VPC and subnet, and if you reveal the private IP, it will show you the IP address, port, and the details as well. So you will need this in order to connect your application to this data source through orchestration or without orchestration. You need this anyway. So whatever you see right here, these are private network configuration details. We need to paste it somewhere so we can use it in the application. In my case, I already have this uh, set up in a cluster and instance. So I'm not copying it right this second because I'm going to go through the other instance that I already started this in. All right. So this is what it looks like. I just wanted to show to you. If it did not give you those quota errors, this is what you would have seen. You can later try it out at your own time. Yeah. So now I'll close this tab because we are done with setting up the AlloyDB part. Now, what I said, remember what I said? We are in step um, grant Vertex AI user role to AlloyDB service account of the code lab. So I'm copying this Cloud Shell command. I'll paste it here. Oops, yeah. So what this basically does is it gets your project ID and it creates the service account of AlloyDB and it grants it Vertex AI user role. It is telling AlloyDB user, now you can talk to Vertex AI. That's basically what that command does. Next is to create a table. All right. So creating table, so what are the tables we have? We have transit policies. This is to store policies of the buses or basically the whole business that we have, which is the symbol transit, right? So whatever we have as policies that is being stored here. It is already converted into structured data. It was unstructured once, but I converted into structured data and it's stored here. And then we have intercity bus schedules. This will have the trip details. This is the actual lookup, like the source data as to how many cities are served, what are the cities from and to, and what is the duration, what is the start time, what is the reaching time, all those things are here. And the booking table is a transactional action data. This only gets data if you make any action. So I already have these tables created. So I'm going to run this and show you what the data is looking like. Let's do that. You don't have to do these steps because I'm going to give you the data endpoint. Just watch this so you can see what data you're dealing with. So here I have 3 records for policies. I have pet policy, I have luggage policy, and refund policy. As you note here, it already has the values. And where are these values coming from? It's coming in from the same step in the data. So in the code lab under data ingestion, as you can see right here, transit policies, I'm converting the policy text into embedding by running the embedding method on the model text embedding using the model text embedding 005 from Vertex AI on the text that is the policy text. All right, so I have 3 policies for pets, luggage, and refund. The next thing, I'm inserting records in the bus schedules table. So let's go and see what it looks like. So the bus schedule has the trip ID or origin city, destination city, departure, arrival, everything. Seats available, ticket price, and so on. That's it. And then we have the table for bookings. It doesn't have any data in the beginning because you're just deploying it, right? Afterwards, it'll have data once you start testing your app. That's it. So our data are ingested. Now we are all set to understand what tools we are going to use for this agent and what is Toolbox, right? So we already have the database set up right now. You also have it. I'm going to give you the data endpoint. We have 3 tables. We have all the data that we need in these tables. Now, our agentic application, which the user will interact with, needs to talk to this data source. So in order for your data source to be edible for your agent or a multi-agent system, you need to make sure it is exposed in the form of understandable context, right? That's what we call tools. Tools are contextual or sometimes runnable, sometimes services. You can assume tools to be kind of microservices or even smaller than that in some cases, which are capable of performing a specific or intending to do a certain activity, right? In our case, let's say booking a trip can be an activity that can be a tool. Finding a bus schedule with the to and fro or a start origin location and destination location could be a tool. So any target action based contextual service is what we call as tool. Anything that can be categorized into a bunch of statements, or when I say statements, these are not prompt statements, these are executable statements, like programmable statements, right? So that's what we call as tool. Tool is anything that your application can do either independently or in collaboration or in integration with other components. So your agent needs to talk to your data source through these tools. So how are we going to use tools? Not directly, right? Because traditionally we have used our database directly linked to our application, which has caused a lot of issues sometimes because your agentic application needs to be changed every single time there is a change in your tool or in your database. And not just that, security becomes an agent's problem instead of rather just being a data problem or data sources concern. It becomes a concern. So every single concern trickles down into all components of your application, which is what we don't want. What we rather would like is to separate concerns, separation of concerns. We have database to do its own thing. We have application agent to do its own thing. And then we have an orchestration framework to conduct your agent. And then the main part, which is the orchestration layer that we are going to use here, is the MCP, which is Model Context Protocol Toolbox for databases. You would have heard of MCP. So what if you've not? MCP is basically a protocol that tells you how to connect your tools to your agents. But MCP Toolbox for databases is a similar protocol, but it is focused mainly on databases, not just for orchestration, not just for connection or integration, but also for security, observability, setting up, monitoring, and a lot more capabilities, right? So recently we launched MCP Toolbox for databases, Java SDK. We also have Python SDK. We also have JavaScript, TypeScript, and all that, Go, and all that. But recently, late February, we launched the Java SDK for MCP Toolbox for databases. And that is what we're going to use today to make our data sources, that is tools, talk to our agent. So what does this mean? Does this mean your tools can only live in AlloyDB or only in the databases that Google Cloud supports? No. You can have data or tools written on multiple databases, even databases that are provided by other cloud platforms or even independent databases or data services. Or you can write your own endpoints for that matter, your own HTTP services. You can bring many number of data sources and have them anchored in one MCP protocol server, MCP Toolbox server for databases. So that's exactly the power of MCP Toolbox for databases, so that you're not just vendor locked in, but also not just not vendor locked in, but also able to handle multiple tools across platforms, not just across agents, and handle them all as part of your multi-agent system. So we're going to use that today in the application. So how are we going to use it? So this is also a step that you don't have to do. You can just watch me do it and I'll explain what it does, because the endpoint that I'm going to give you for the data is of the MCP toolbox. So directly you can use that in the agentic application that you will build. You will be building starting step 6, the next step. This step you don't have to do because I'll give you the endpoint. All right. So I'm going to set up the MCP toolbox server for 3 tools or maybe four tools. The first tool is finding bus schedules. Next one is finding like querying specific schedules with origin and destination locations. And then booking tickets is another tool. And searching policies for the trip. That is another tool. So 4 tools. So what is a tool? In this case, MCP Toolbox allows you to write just a YAML file or even generate a YAML file visually, and then write queries. So you might be thinking, oh, in that case, do I have to write queries for every single scenario that the user may encounter or the user may ask? Not necessarily. There's a concept called NL to SQL in AlloyDB and in MCP Toolbox, which allow you to have open-ended query, open-ended interaction between your agents and tools, but we're not covering that today. So we'll just go with what we have, which is this YAML file. So I'll show you how I'm going to set this up. All right. So I'm going to create this MCP toolbox directory just to make sure I have a brand new folder for this project. It's just for the MCP part, right? So I'll make directory symbol bus toolbox. It is created, and then I navigate into that directory. Cool. Now I'm inside the directory. What I'm going to do is I'm taking one of the most recent versions of Toolbox, and this is actually downloading the binary and storing it in this folder that we just created. So hit enter. There we go. There's not enough space, so it says it cannot do it. But maybe I already have this. Let me just quickly see. Do I have it? Do I have it? Okay, maybe I'll try here. I'm just trying to show you what it looks like, the YAML file. All right. Okay, there we go. So the toolbox is actually downloaded, right? The one that we install right now, that's already done. I'm going to show you where this, where is my symbol? Tools.yaml. Okay, so this is the tools.yaml, which I showed you there. So this is what we have right now. We have to define the source, how it's connected, all right? And then we authenticate it with a deployed version of your MCP endpoint, which is what it already does. Meanwhile, I'll open this workstation. So since I don't have enough space here. Just bear with me for a minute. Yeah. All right. So here we go. This is the toolbox that we saw. We have to authenticate it based on the deployed toolbox endpoint. So how will we deploy that endpoint? I'll come to that in a little bit. But just know that we have the tools.yaml, and then we have a deployed endpoint. For the first time you're running this tools.yaml, you will not have a deployed endpoint. You'll have to come back and edit this tools.yaml to paste the same deployed endpoint of your application here, and then go to tools. And these are the tools we already looked at in the code lab, and we have already covered it. So we don't have to revisit that right now. Now I'll show you how to install this toolbox and get the tools.yaml to run in your local. Basically, it's a very simple step. We created the folder and then we download the binary for Toolbox and then directly create a new file called tools.yaml, just like what I showed you right now. And then go down to the code lab. You can see you can either run this command to open it locally or directly you can test it by deploying it to Cloud Run. The reason we are deploying it to Cloud Run is because you want the MCP orchestration layer to be accessible by all of your applications, not just or anywhere that your agentic application. So we want to deploy it as in Cloud Run rather than having this toolbox server running locally, because your application should be able to access this. And the whole point of having it as an individual or independent service is so that it's accessible for your agentic applications. All right, so I'll have to wait for this workstation to launch because I need to run these commands for you. All right, so let's say we have our tools.yaml created. We have toolbox binary downloaded. Now we are just able to run this command. We have already enabled services. So just this one command right here, which is gcloud run deploy. This is the name of our endpoint for toolbox symbol transit. And then we provide with all the parameters that we need to for this one, and we have our tools.yaml stored as a secret. The reason we are doing this is your toolbox deployment requires your tools.yaml to be accessible, and for it to be accessible for this particular command, we store it in a secret. And then we make it allow unauthenticated because we want our toolbox endpoint to be accessible by all our applications. If you, for your production application, you want to use service account, you can do that as well. But for the demo purposes, since if you're using public network, use the first command. If you're using a private network, use the second command, and you will be able to deploy our AlloyDB data source as tools that we declared in the tools.yaml and use Cloud Run deployment to get our data running on Cloud Run. So let's assume we have completed this step. Just because I know that we will have quota issues in installing the all at once. So that's why I have the service prepared for you. So I'm going to give the endpoint that was supposed to be the result of this particular step. All right, so I'm going to share that right now with you all. It's there in the chat right now. So I've pinned that. So this is the endpoint for Toolbox server, which we are going to be using throughout our application in the next 5 to 10 minutes that we'll complete cloning our app and changing the data endpoint. All right. So why do we need this endpoint? Because some of us were not able to set up the database because of the quota issue, right? Yes, to answer the question, getting client ID in the tools.yaml. Let me get to that point really quickly. So the question that's asked in the chat is very valid. We don't have it to begin with. Initially, when you're deploying the tools.yaml to Cloud Run for the first time, if you know for sure this is the name that you want to give in the Cloud Run deployment, and if you know your project number, which you will know, you can declare that this is how your Cloud Run URL will look like. So you will know, you can frame this. While this is not at all available to begin with, you can frame this, you can form the string, and you can include it in client ID. But if you don't have it, that's okay. You can remove this auth services in the first run, deploy this in Cloud Run, and take that endpoint and come back to auth services and put this back. That's all. And then redeploy it. So let me show that really quickly. I'm not going to deploy it right now, but I just want to show to you how our endpoint is placed. And this is exactly what your endpoint will look like. The only things that will be different is your project number and whatever name you provide for the toolbox endpoint. So I hope the takeaway from the steps that we discussed so far we have just set up AlloyDB database. We have created the table, created the data, and then we went into MCP Toolbox, which is the orchestration layer between the tools and our agentic system. So this toolbox will have nothing but one file, which is tools.yaml, which hosts are tools, the 4 tools that we need for this project. And these 4 tools are available as part of this tools.yaml, which I already showed right here, right? Let me open my active project so I can actually show you what the final tools.yaml looks like. There we go. So this is the tools.yaml for the deployed link that I've shared with you. Is this the one that I shared with you here? Either that or this. Either one will work. All right. One is with the, so let's go with the second one. So go with the second link that I've shared with you, right? So why are we looking at this? Why is this important? Because this is the tools.yaml. When you're deploying this into Cloud Run for the first time, you will not have this client ID. That's okay. You can just leave this part out and deploy it and then come back, include the deployed endpoint here, and then test your, like replace this client ID with your deployed endpoint. That's pretty much it. So why did I share this endpoint with you? Because I asked you not to do the data part, not to do the MCP part, so that you can listen in, because all the deployment and everything will take a few minutes, right? We cannot accommodate all the steps for everyone answering questions. Why? What is the issue? We can't address that. So I made available, ready to go MCP endpoint, so MCP toolbox endpoint, so we can all get straight to the application development part. That's it. So now let's head to the next step. I hope you all understood the point, like what is MCP toolbox and why you're using this. Show of thumbs for like people who understood. Can you please confirm that this was what is MCP toolbox, why we need to do this, where it is placed in your agentic system, and all that. All right. Yes, the /toolbox in your local may not work for everyone. The reason is your Alloy DB is private, right? So your public network, unless you enable public network, it won't work locally. Directly deploy it in Cloud Run, Kian, if that helps you. Yeah, perfect. Now let's move on to the code lab and go to the next step, which is agent application. So this is the part you all want to start getting hands-on again. So far, we have set up the data, we have set up Toolbox. Toolbox, just imagine this as a center, as an orchestration layer between your tools and your agent. That's it. Now, we have to set up our application for the agent, which is also straightforward. This is a clone command. So copy this git clone command, come back to your Cloud Shell terminal. Yeah, come back to the Cloud Shell terminal. Make sure you're in your root directory by typing cd. Come back to your root directory. All right, so I'm here right now in my root directory. Go ahead and paste the git clone command that you copied from the code lab. There we go. It's not showing my project ID, so I'm going to adjust that a bit. Gcloud config set project. If this happened to you, you also need to set your project ID. Okay, perfect. So now I'm going to paste the git clone command, which is copied from the code lab. Git clone and the repository that it's showing, and hit enter. In my case, it already exists, so I'm not going to create it again. So please go ahead and run the git clone command in your terminal. All right. Now go back to the code lab and go to the next step, which is change directory, which is basically going inside the repo and going into the subfolder and going into the project folder symbol transit. So copy that from the code lab. You have to follow these steps, starting step 6 of the code lab, which is git clone. And then the second step, which is cd, navigating into the symbol transit folder. So paste that and navigate into the folder. And as you can see, What happened? 1 second. Okay, so I have a different folder there. Don't worry about it. Just follow what is there in the code lab. We have already cloned the project into just git by using the git clone command. Let me clone it again because it's taking me to a different place. But it's because I already have this project. That's why. Don't worry about it. Just follow this command. Copy this git clone command. I'm just repeating the step because I have an issue. That's why. But I'm going to run it right now. Again. Why is it so slow? Yeah, here we go. All right, so I've cloned by using the first step. Now I'm going to copy the second change directory part. All right, so CD. You can copy it directly from the code lab. I'm not copying it because I changed the name of my landing folder. Don't worry about that. You just copy what's there in the code lab for CD. Yeah. All right, and hit enter. Now I'm inside the working directory, which is symbol-transit. So this is the project that we want to be working on right now. Now that you're in there, it should create a project in your editor. Now toggle between editor and terminal by clicking the open editor button in your terminal. You should be seeing that. In my case, I'm not seeing because I'm using a workstation. Don't worry about it. You should be able to see this open editor button or the pen icon right here. So open that editor and you should be able to see what I'm seeing right here. This project structure. You should see symbol transit. You should be able to see the source directory, the main symbol, the Java Cloud Code symbol directories, and then you should be able to see the resources folder and so on and so forth. Yeah, so you should be able to see all of those things. And once you see that, come back here. We'll do a quick code walkthrough to see what is there in the code, and then we'll jump into the next step, which is running the application. We'll first deploy it on Cloud Run directly, and then we'll test it out. The reason is if we start testing it locally again, once again, we might run into issues. So we'll do a direct Cloud Run deployment while we change all the necessary variables instead of running it locally. But let's look at the code first. So the only thing that we're going to walk through in the code is a symbol transit controller or Java, which is inside the source directory under web. So what we're doing here is basically we have, like I said, we have environment variables for project, region, model name, which is, in this case, we are going to use Gemini 2.5 Flash. You will see that in the variables that we are passing to Cloud Run. And then we have a prompt instruction for system instructions that will tell what this main agent is supposed to do, the transit agent is supposed to do. And then we have a toolbox bridge, which actually connects all the tools that you have defined in your tools.yaml to your agent. So that's what you see defined in these in this particular service, in this particular class, the 4 tools that we have defined in our tools.yaml. You don't have to define everything here. It is just a reference to what you have used in the tools.yaml. And then comes the part where the main part where you initiate the whole thing by passing in the credentials using Google's application default credentials. And then you pass you define the methods for find all schedules, what it needs to do with the response, right? Basically, when this tool is called, what happens with the response? So those definitions are defined in these methods. So that's pretty much it. The only other part which you need to replace is the endpoint, which is defined in this variable called, I'll tell you what the variable name is, MCP toolbox URL. So we have to define it, but don't worry, we'll define it all together in the Cloud Run deployment step. All right, so this is basically what the code does. It basically has a root agent and a couple of sub agents. All of these are designed in a way that they can talk to the tools, the 4 tools that we have defined in tools.yaml. and defines whatever it needs to do, each of the tool needs to do with the response. And finally, we are using the toolbox as an orchestration layer to pass the endpoint directly as a data source, instead of, if you see, nowhere in the code we have a LoyDB connection or anything. So if you change anything, for example, if the price of the bus changes or any logic changes in your database, you just need to tweak your toolbox layer. You need not touch your agentic layer at all. All right. Now, going further, let's do the Cloud Run deployment. Go to step 10 in the code lab. We have already discussed the toolbox significance early on. So we are going directly to step 10. All right. So go to the part where you have cloned your application. Show of thumbs, how many of you were able to successfully clone your application? It's just clone your applications, right? There should not be an issue with cloning your application in your local. That's it. Yeah. It should be straightforward. You clone the application and you navigate inside using the CD command. That's it. Now, making sure you're inside the root directory. All you have to do is go to the code lab, go to step 10, copy the gcloud run deploy command from there. Copy it or wait for me to paste this in the chat. Paste this somewhere because we need to modify a few things. What do we need to modify? If you're able to see my screen right now, I'm modifying it right in front of you so that we can all do it together. You see the toolbox endpoint that I shared with you all in the chat. So we are going to go back to that, copy that endpoint, come back and replace the MCP toolbox URL with that value end to end, right? And then project ID placeholder, including the angle brackets. You need to change that to hold your project ID. Next, region, leave it as it is. Gemini model name, leave it as it is. That's it. No, nothing else needs to change. The only change in your case is replace your project ID and the endpoint, which I shared in the chat. If you don't know what it is, I'll share it again for folks who probably accidentally missed it out. Okay, thanks, Mahesh, for that. Yes, you can see agent visualizer, but this is not a low-code agent. This is actually a code-driven agent. You have visual representation for MCP, but let's deploy this and explore how to do that later. Yeah, we are doing it the code way. There is no. Yes, what we did yesterday was simple, like fully. What do you call that? It's an out-of-the-box solution with drag and drop style agents. It's not really code driven or some customize. It is customizable to a certain extent, but not programmable. But what we're doing today is an open source framework. We're using LangChain4J. If you look at the code in the controller, you will see where you've used LangChain4J, how you've used the services to interact with MCP toolbox and all that. Right. So that's exactly how we are doing it, programmatic way. But there is a way to visualize toolbox server. We are not going to do that right now. I'll show that after deployment. Now that we have changed the environment variables, paste it here in your Cloud Shell terminal and hit enter. Sorry, I didn't copy it. Let me copy it and paste it. You also go ahead and do this and hit enter. It'll ask you for region of deployment, say US Central 1, which is 35, number 35. It'll take a couple of minutes here, or maybe if it's fast, it probably will get done in 1 minute or so, but let's give it some time. So once this is done, what you'll see is the application deployed and running in the name Symbol Transit. I think I already have it running. I can open it, but let's still wait. In the meantime, I can show you also how to visualize it. Yeah, uploading sources right now. Yeah, I can paste the command here. It's just that you still need to change your project ID. You can't, you need access to the project ID. There is a placeholder. Yeah, so this is the command you use, but remember to change the project ID there. Yes, you will get a recording of this. So it's doing the build process. So let it run. In the meantime, if you can see my screen, this is what your deployed application will look like. You can directly interact with it. Just say, hi, can you tell me all the routes? There we go. So it is able to interact with your database through MCP Toolbox and is able to provide all the unique routes that are currently available. But do you think we stored it uniquely? No. This is all through your agent. Your agent is intelligently able to understand the data. If you look at the tools.yaml query, you will see the fine bus schedules. We are just getting all the trips, departure time, and everything, and we are just leaving it there. It's the intelligence of your agent and the connectivity that you have with MCP Toolbox that is allowing it to fetch the unique cities that are available and the unique routes that are available and list it to you, right? So this is why we call it actionable, agentic. This is why we call it actionable. Now I can say, show me routes between Boston and New York. All right, so mine is in the last stage of deployment, which is creating revision. Anyway, that will go on for a bit. Meanwhile, let's just interact with the agent. How many of you got your deployment complete already? Okay, in progress, show of thumbs. In progress deployments. See, when I'm copy pasting here, it's possible that there are some, you need to replace that's why I said copy the Cloud Run deployment from the code lab and make change for your variables accordingly. Looks like you're trying to copy from chat, and obviously it'll have some. No problem, take your time. You will have time. This is an L300 level lab. It's not supposed to be done in 1.5 hours. We um, wanted to do this because it's more about the architecture when you're building your own applications with it. And you have to take it back and try it out at your own time. That's why it was simplified to give you the endpoints, and you just have to clone the application and deploy it in Cloud Run. That's all during this session. Yeah. All the links will be shared. All right. So anyway, while we were speaking here, my application got deployed successfully. So I can open that now and test the same application. Or we can continue the discussion that we were already having with the previous agent that I already deployed. If you, yeah, it's the same thing, I guess. Same, I use the same name, so the same app showed up. Anyway, so if you can see the routes between Boston and New York, it was able to fetch literally everything that's there. So now I'm going to say book trip ID or book trip for a B. So if it is asking me to provide a trip ID along with the name. So it's saying I can help you book a ticket, but give me your trip ID. So I'll just paste it because it is actually giving me the trip ID. So I copied it and I'll paste it. And now it should be able to provision the ticket for this. There we go. It successfully booked a ticket and the booking ID is confirmed. And if you notice, this particular booking ID previously had 7 available tickets. Now I can ask a question. How many tickets are left with this trip ID so and so? Now, there is no specific query defined for this question in the tools.yaml, right? See, but the agent was able to successfully derive that for us. This is the intelligence of the natural language querying to the question, user questions to conversion of queries. Number one, even though we haven't used NL to SQL here, Since we have exposed all the data through our first tool, if you see the tools.yaml here, I told you we have explicitly mentioned here is all the available bus schedules, here is all the bookings data. The agent itself is intelligent enough to understand the data that you have. Since I have loaded all the data to begin with, it automatically booked your ticket and tells you that it looks like you have 6 tickets available for this trip remaining, trip ID remaining. So that's or 5 tickets left for this particular one. So that's exactly what how intelligent your agent gets based on the tools that you're defining, right? So you can go ahead and ask questions about policies. Tell me if I can bring my 1-year-old golden retriever puppy. So based on the available information on policies, it is doing a vector search here because that's exactly what we have defined in our tools.yaml. So it is saying large dogs are not permitted, but you can bring small pets under so-and-so fee. So that's pretty much it. This is the session for today. For result submission, you just need to take a screenshot of this agent conversation. That's it. And then paste it in the URL. However, I know that this is a complicated lab. It was not meant to be L100. It was not meant to be completed in 10, 15 minutes. You were supposed to go through this journey of setting up database, setting up MCP, doing it end to end. However, because of the time constraint and also because of the resource constraint in terms of the trial billing account and the resource exhaustion, I was already prepared to give you the endpoints. So you don't have to build the database at your end. You can just directly use the endpoint for MCP. What I want you to take away from the session is that understanding of Toolbox. What is Toolbox? Why do you need it? So I hope that part is clear for you all. If it's not clear, go to step number 8 in the code lab. It explicitly talks about what MCP is. I explained that to you. It's like a USB-C, a universal USB-C for your AI applications. It basically converts or allows your tools to talk to your agents. What is MCP Toolbox for databases? This is an open source service from Google that connects your database tools to your agents, but not just restricted to a particular platform or provider, but across platforms, across databases, and across enterprises or any particular provider that you have. And what we are using, the Java SDK for MCP Toolbox. So we are able to consume tools. We are able to ensure type safety. There are so many things we've done in this application, which you probably did not experience in this session. But if you go through the code, you'll understand why we have done what. And the only thing we have done in the pom.xml is include this dependency. If you compare it with Python, is the requirements.txt in Python. That's the pom.xml for Maven applications in Java. And here we have included the MCP Toolbox dependency 0.2.0 version. And this is why we are able to use MCP Toolbox. And we have used LangChain4J library for the agent framework itself. Ideally, you would have used ADK. In yesterday's session, you used the Visual Builder framework, but in today's session, we used LangChain4J because we didn't want to just tightly couple all your frameworks within one provider. So we just brought in LangChain4J, which is LangChain is quite popular. So LangChain4J is popular, equivalent. It's equivalent to its Python variant, LangChain4J for Java. Now, for someone who asked, how can I access this visually? There is a way. When you deploy your toolbox, if you go to step number 5 in the code lab, scroll up top, there is a command that says /toolbox space -- UI. Running this command will open up your tools in a interactive user interface that will allow you to test your tools directly in the web UI. So that's why this tool is useful. But for this to be tested, you need to make sure your database is locally accessible, in which case you have to make it public or you have to allow list your IP address for your local machine in the place where I showed you, where you can enable public IP or where you can enable whitelisting a particular or allow listing a particular IP address. That's pretty much it. So for result submission, go to step 11, the demo part. If you demoed it, if you completed the application cloning and cloud run deployment, the last screenshot is what you will be able to test by yourself, as I showed here. And this is the screenshot that you need to submit for today's result, today's lab. I know it's a difficult one, but I hope it was useful for you in understanding the concepts and architecturally. Yes, you will get a recording by morning because since it's a lengthy 1.5 hour session with so many folks joining in, processing time will take a few hours, which will be past midnight. So you'll be getting it first thing in the morning. Okay with live session too, but just note that the top submissions will be the ones that are completing along with us, and they'll probably submit it. But it doesn't matter. You will still be a lab champion and will be recognized. The top 25 will be the folks who submit the results as part of the session. Show of thumbs, how many of you were able to successfully deploy it in Cloud Run and get the result for the agent? Yeah, you got the agents. Cool. Again, in tomorrow's session, um, we have A to A framework, but that's a Python application. I don't think we have MCP toolbox in that. We will just be building a visual Gemini visual model driven agent. So that's also pretty intriguing. I'll make sure that for the next session onwards, like not for tomorrow's is possible to complete in an hour, pretty much straightforward. But the session afterwards, I'll make sure that we get to the end point straight away. And all of the remaining sessions, the next 3 sessions are in Python. And so a good news is that we have one more project that is created by another developer advocate in Google, and that is scheduled for Monday. I know that this was not a planned session to begin with. However, you feel free to attend on Monday, in addition to all the five sessions that you complete this week. Yeah. Again, we have only 3 lab submissions this season. You don't have to submit sessions or lab results for all the sessions this season. However, if you submit, it's great. Your score will go up. Yeah. Yeah, so sorry, folks. I dropped out because of battery. But what I was going to say is you will get the details and everything related to the recording session, the session's recording and other things in your email. Yes, the session's done. Um, you will get all the necessary details. My laptop died and I had to kind of change the room and connect it into power. So that's why I dropped out abruptly. I'm looking at the questions. How to submit screenshot? You would have received it in email, Shirin, if you're still there. If your agent is not responding, what could be the reason? I have to see your logs if the agent is not responding. First thing is maybe you haven't, the allow unauthenticated is probably not working. But we need to look at your logs for more things. Yeah, Shirin, you will have it. You would have registered, if you registered, you would have received it in email. I don't know when you registered. If it's last minute, you will get it along with the session recording. I'll send the details about uh, where to submit. But if you need your user credentials. So if you don't have an email, you probably don't have your credentials also, which you'll receive an email tomorrow. For this session, you could use the Toolbox endpoint that I gave. I will also send that in email when I'm sending the recording. But in real world, you will use your Toolbox, your own Toolbox, tested in local but deployed in a server. Jesse, for your question about projects and AlloyDB resource killing, you can just delete the cluster and instance automatically. You don't have to kill your project. Just go to AlloyDB, click the three dots in cluster, and you can delete it. The instructions are there in the code lab for that. Yes, we're done. Thank you, everyone. So hope to see you in tomorrow's session. We'll make sure that we cover the details that we intend, whether it's architecturally or the hands-on part. Both will complete in time. All right. So let's meet again tomorrow. Talk soon. Thanks, everyone. Bye.